Hello. Hello. Hello.
Hello.
Yes, yes. So when? So
Uh,
we need to fix a date for the tutorial. So you said last time that you people said that you will decide among yourselves and let me know in the next class. So please let me know when.
Sir, actually, we still have time to decide the electives. So some students are still deciding their electives, which might uh, like, which might collide with the date if we
But
decide
the thing is
right
that we
now.
cannot wait for the indefinite time, right? Like 2 weeks or something. This is not possible. At least from the next week we should start the tutorials.
Uh,
So you understand? Uh-huh.
so can we tell you on by this week, by the end of this week?
At least on Monday you should tell me then.
We'll tell you by Monday, sir.
Monday. Some date you fix some date around I said no in 6 o'clock, 7 o'clock, everything, anything is fine. So decide.
Okay, sir. Okay.
Okay? And please
Yes.
let me know. Okay.
Yes.
Okay. So let's start. So is the other classes going on? Hello? Is some other classes going on? So students are not coming?
Yes, sir. Graph theory.
Huh?
और ये सर एक क्लास ग्राफ थ्योरी
Graph theory is going on?
सर
I said, but I cannot wait in like this, like 5 minutes, 10 minutes every day. Anyway, I start. Let others whatever they do. Okay. Can you see the whiteboard?
Yes, sir. It's visible.
Okay, good. So let's start with the definition. We say a kth ordered PDE is fxu is a function is an function of u unknown function of u and its derivative which looks like the expression of this form fx ux dux and dkx. You know what is dk ux and all those things. It's called a semilinear semilinear, quasi-linear, and linear. So can you give me an example of a linear? Just recall. Yes or no? What is the example of a linear PDE?
Laplace equation.
Laplacian. What is the semilinear? Example of a semilinear.
Laplace plus u square equal to 0.
Quasi-linear.
U multiplied by the previous. U into Laplace plus u square.
And what is the and fully non-linear? Huh? Fully
Laplacian square equal to 0.
like this? Huh?
Yes, sir.
Okay. So you know now I will define a new thing, a new notion. So you know what is the definition? I said what is the definition of a solution, right? Before definition, one remark I should say. I should start with a remark. Okay. For a PDE, we look for solutions. You know what is the definition of solution? I did in the last class, right? Yes or no?
Yes, sir.
Which satisfies some, like OD, satisfies some boundary condition, right? Or an initial condition. Yes. So for a PDE, we look for solutions which satisfies some boundary condition or some initial condition. You understand what is the meaning of that? What a boundary condition and initial condition? Yes or no? Did you know these things? In ODE you have seen, right? Given an ODE. So till now I am writing just the expression of this form is called PDE, where U is an unknown, right? UX, then we have DUX dot equal to 0. Okay. So that expression. So we look with the equation with some boundary condition. Okay, we look for a solution for a PDE with boundary which satisfies this type of expression with a boundary condition plus a boundary condition. That should be the natural, right? We'll see why. Conditions. Okay. You understand? Like ODE, we always give a first order ODE, we always give us some initial condition or something like that. Okay. In PDE, either we have a boundary condition or some initial condition. So we look for a solution which satisfies this expression f of x ux this equal to 0. And also it satisfies the boundary conditions. Okay. Okay. Now a definition, a new definition. We say, this is very important, this definition. We say a PDE, this is very important, is well posed if one, it has a solution. Okay, you understand what is the meaning of that? It has a solution. Second, the solution is unique. And third, the solution depends on the initial condition continuously. Depends continuously on the initial condition. On the initial condition. So you know what is the meaning of the solution depends continuously on the initial condition? Anyone? Anyone?
A slight change in the initial conditions does not change the solution very much.
Exactly. Very good. Exactly. The thing is that it is supposed having, so the solution does not change very rapidly. No, it's not. Solution does not change very rapidly from the initial value. From the initial, roughly you can say. This is not mathematical term. This is just a rough term. Initial condition. Okay. Okay. So we say a PDE a well post if it has a solution. That means it should satisfy this expression and also it satisfies the boundary or a initial condition. Okay. Initial conditions. Okay. Okay. It has a solution. The solution is unique. You know what is the meaning of the uniqueness. And the most important, the third point is solution depends continuously on the initial condition. That means that roughly it says the solution does not change very rapidly from the initial conditions. Okay. Is it okay? You understand? Everyone understand?
Yes, sir.
All others?
Yes, sir.
Clear? Okay. Okay. That then we call a PDE a well post. A PDE is said to be a well post if it has a solution. So now you can ask me, so are there any PDE which don't have a solution? Why then I am imposing these conditions, right? Why I am saying that the PDE is called I am coining a new term which is called well post, right? Why I am coining this new term? So there we will see in the later class that this is a very important example. It's called Levy's example. It was proved in not 1957. But he says that there exists a function. There, of course, there exists a function f of xyz, which is defined as f1 of xyz plus I into I is the complex xyz, which is a C infinity of R3, such that the PDE minus ux minus iuy plus 2i x plus iy into uz is equal, just this is for your information, xyz in some omega has no solution for any open set omega, has no solution. So there is an example, we can cook up an example from the Lewis example. One can see that there exists a function f such that this PDE has no solution in any open set of omega. You understand why means xyz in omega. So there is no solution for any open set omega. So this PDE is not well posed. This is not well posed. Of course, the proof we don't have to see. We will see later if possible. This is not well posed. Okay. So because this well posedness is a definition. So we say a PDE is well posed if it has a solution. Second, the solution should be unique. And the third, the solution depends continuously on the initial data. That means the solution should not change very much from the, so it should change very continuously with the initial conditions. Okay. And this is an example of a PDE which is not well posed. Okay. Okay. Now we will be doing mostly the first order PDE. Okay. First, we will do first order PDE. For the first 2-3 weeks, I think we need 3 weeks to first study the first order PDE. Okay. First order PDE. So until now we have done what is a PDE, what is a multi-index, what is the solution of a PDE, when the PDE is said to be a well posed, and some examples of PDE and the classifications of PDE. Okay. So until now we have done this. Now we will solve some PDE with using some analytic method or some geometric method. We will see. Okay. So it is mostly based on the geometry. Okay. We will see. Okay. First we will first study a class of PDE which are first order PDE. Can anyone give me an example of a first order PDE? Yes. Can anyone give me an example of a first order PDE?
ux plus uy equals to 0.
Very good. Very good. Okay. Very good. We will do the first order PDE. Okay. Okay. Let me start with this example, as you said, or we can do it this example. Okay. First, let us solve some PDE, first order PDE, and then we will try to generalize this method. Okay. Okay. You understand? Let us solve some particular examples. Clear? And then we will try to see how we can generalize this method for any general first order PDE. Is it clear to you? Okay. So let us start with an example. As she mentioned, this example, consider the problem. UX one problem finding UXT satisfying UT plus AUX equal to 0. T is positive and X is in R, and U naught of X is equal to some H of X. X belongs to R. Where A, and this A is nothing but A belongs to R, a constant. A constant. Okay. Okay. Can anyone solve this PD? Case 1. Anyone? Suppose first case I assume A is 0. So the PDE turns to u2 is equal to 0 and u at the point 0x is given by hx, where t positive, x belongs to R, x belongs to R. So when A is equal to 0, then the PDE turns to this. Can anyone now tell me what is the solution of this PDE? Quickly.
T square minus 2tx. T square minus 2tx.
What is that?
T square
ut is 0. U2 is 0.
Oh, sorry, sir.
No, it's okay. So it is independent of, actually this is constant, ut is 0. So what you can say? So u does not depend on,
U is a function of x.
u is a function of x, it means. So what is the solution? So this imply u is a function of x only. Good. X, function of x only. That means u of 0 comma x should be equal to u of is it true or not? Yes or no? Because
Yes,
ut
sir.
equal to 0, that means ut is constant along t, right? In t, so ut equal to 0 means u is a constant in t. That means u, the point, the function for any x, u0x is equal to u2x, utx for fixed some x, and you vary t. So u is a constant. So u is a constant in t. So what is this? Solution is, and what is u0 of x? H of x.
H of x.
Exactly. So the solution is, ut of x is h of x. This is the solution. Agreed or not? Agreed or not?
Yes, sir.
Okay. Now little bit a difficult case. Case 2. When a not equal to 0. That means we have to consider ut plus aux equal to 0 when t positive, x belongs to R, and u0 of x is equal to h of x. Okay. Okay. Now how to solve this? Any idea?
The dt by 1 like that equal to dx by d.
But is a t is a x is there? How will you solve? Try to see some geometric way. So what is this? This is a diagram, right? What is the domain? So this is your t positive and this is your x. Right? So your domain is here. Right? Yes or no? Yes or no? The domain is this.
Yes, sir.
And what is the initial condition given? U naught of x means here. Right? Here it is given that this initial condition is given, right? U naught of x is hx. Now what you have to do? You have to, utx is a solution of a PDE which satisfies this and u. So you have to find some, for any xt, you have to find a u such that uxt satisfies this equation and u naught of x equal to hx. What you will do now? Any idea? Can anyone? Try to think in a more geometric way. Any idea? Okay. So this is your domain. So you have to find for every point x comma t, you have to find a u solution utx such that it satisfies this PDE and it should satisfy also the initial condition, right? Okay. Now let I define a curve in R2. I can define like this, a curve in R2. Okay, gamma of S as T of S, comma X of S. This is very important. If you understand this, then you will understand the first order PDE. Okay, please try to understand. I define a curve gamma of S is as T of S X of S. So this for S belongs to some interval I, interval in R, interval in R. Yes or no? Okay. Now I say that define a function V of S as U of gamma of S. Okay. I take U to be any function such that V of S is U of gamma S. Is it clear? Yes or no? If unless you tell something
Yes,
I
sir.
cannot understand. Yes? Okay. Please interact. Now I said differentiation. V prime of S. Sorry, this is U of gamma S is T of S and X of S. Okay? Okay. Now what is V prime of S? V prime of S is UT chain rule T prime of S plus UX as into X prime of S. Chain rule. I use the chain rule. Clear? Is it clear?
Yes, sir.
Very good. So V prime of S we obtained as UX, sorry, UT at the point TS XS into T prime of S plus UX at the point TS XS into X prime of S. Clear? V prime of S. Now suppose T prime of S is equal to 1 and X prime of S equal to A. Then what, and U satisfies, and let's say U is a function. Let us, we want to find the solution, right? So first let us suppose that U is a solution of this PD. Suppose, we will see if and only if. Okay. So what we have? V prime of S as, suppose I put this. So UT at the point TS I am not writing, plus A of UX. Yes or no? Yes or no? If I suppose T prime of S equal to 1 and X prime of S equal to A, then the V prime of S is UT, TS is 1, X prime of S is A. The equation, and U solves the equation. So we want to find the solution. Okay. Let us suppose that U is a solution. Then we will see how the U looks like. Okay. So V prime of S is UT plus AUX. So if U is a solution, then it has to be 0. Yes or no?
Yes.
Yes.
Everyone agree? Whenever you have small doubt, you ask me. This is very important, I must say. So we have 3 equations, right? T prime of S equal to 1, X prime of S equal to A, and V prime of S equal to 0. Now tell me, what is this? T prime of S equal to A means? Huh? T prime of S equal to 1 means, sorry, T prime of S equal to 1 means TS looks like, TX looks like
S plus C.
S plus some T naught. Okay, very good. X prime of S equal to A means X of S looks like, huh?
AS plus T1.
Etc. Let's say. Oh, these are the initial. What is the meaning? And now, okay, now we have this. Now you tell me, what is the curve this? So your gamma S, you have gamma S is your TS XS. If this was 1, so your gamma is S plus T naught, comma AS plus X naught. If I write properly, this is S into 1 comma A T naught X naught. Your gamma of S is. What is this curve? Who will tell me? What is this curve? What is the parameterization of this curve?
It's a straight line. It's a straight line.
Exactly, with slope A. This is just a parameterization of a straight. You just write down. You can do it. TSC and X and Y. You just substitute. You will get this is a straight line with slope A. So gamma S is nothing but is a line with slope A. Okay, and we also have V prime of S equal to 0. What does it mean? So V prime of S equal to 0. What does it mean? Can you tell me geometrically? V is constant along. V is constant along. What is Vs? V prime. What is Vs? Vs is U of gamma S. So we prove that V prime of S equal to 0. What does it mean? Huh?
That U is constant along the line that we have described above.
Exactly. V is constant on omega. This implies V is constant. V is constant on gamma. If gamma is a straight line, because we know this is a straight line. If gamma is because when this is constant, it is 0 when t prime of s equal to 1 and gamma prime of s equal to a. That means V is a constant on gamma if gamma is a straight line. So straight line with slope a. That means this equation with slope a. Is it clear? Okay. So what is it now? Draw pictorially. So what we obtained? So let's say this is the slope A. So along this line, we obtain that along this line. So this point, the V is constant along this type of lines. Okay, this type of lines. Is it clear? So here the value of V is equal to the value of V here, everywhere. Yes or no? So V is constant along these straight lines. Is it clear? With slope A. Is it clear? That means so V of S is equal to V at 0. That is U of P0 because V of 0 is defined like that, X of 0. That is U. What is T of 0? Can anyone tell me what is T of 0? This is a T gamma S is Ts XS. Okay, this is a straight line join from here. These are the straight line with slope A. What is T at 0? Because it should hit at
T naught.
Zero. T naught should be 0 because it is hitting the line x-axis, right? Clear? Is it clear? So I say because we have to find T naught, right? But I say that T naught has to be 0 because these are the straight line. These are the straight lines hitting the x-axis. Yes or no? Because there is no here. There is our domain starts from here. So at s equal to 0. Yes or no? A straight line with slope A hitting x-axis, then what should be this T line? T of 0. T naught. Yes, I agree. T naught. What is T naught then?
0.
Yes, because here what is any point here is 0 comma x. Any point here is 0 comma x. Yes or no?
Yes, sir.
0 comma x naught. So what we obtain? V of S is equal to U of 0 comma x naught. So what is V of S now? V of S is U of, what is V of S? What happened? Are you following? All of you following or not? Anyone, any doubts?
No, sir. We are following.
All of you, please tell me if you have any doubts. Until now, is there any doubts?
No, sir.
Clear? Okay. Now you have to tell me. So we have to find, so we have obtained that Vs is constant. V is constant along this line. Now take any point x comma t. You have to find u of xt. How will you find? Tell me. So any point u of xt, how will you find? So I again draw the picture. This is x, this is t. So you any point xt. How will you find u of xt? Huh? What you will do? Tell me. You know that you just draw a straight line with slope a, which hitting the x-axis. You know that the value of u along this line, that is along this line or the v, same thing. The value of u along this line is constant. Yes or no? Yes or no?
Yes, sir.
What is
Yes,
the
sir.
value of u at this point? 0 comma x naught. Because we started with a u of 0x is hx. Because here we know the initial value, right? So this is nothing but h of x naught. Yes or no?
Yes, sir.
So u of at this much we know u of t of s, u of t of s. If we come down here like this, we know that is equal to u of 0 x naught. Clear? Okay. That means now but x naught is any a point, right? So you can you do now? Can you substitute? Can you find the value of x naught? What is the value of x naught? Tell me. Just a minute, I'm coming. 1 minute. You think. What is the value of x naught? What is the value of x naught? Yes, what is the value of x naught? It is clear now. U of
H naught.
h of x naught. Okay, that is okay. But x naught is arbitrary, right? You have to specify what is x naught, right? Yes or no? So any point it will hit here. Any point it will hit here. Some x naught, x naught. So you have to find that point, right? Because u is constant along this line. That means u at tx should be equal to u at 0 x naught. Now can't you substitute x naught in terms of a and something? Huh? Can't you do this? This is a straight line joining the point P and A. So u of Ts. So you should have something on Ts, right?
So you want us to substitute h naught in calculate h naught in terms of h and t
A, T and X. Yeah, exactly.
using the line. Okay.
Exactly. That I want.
Minus point.
Yes, tell me. It should be
Minus
h
t
of
upon
x minus 80. हो गया. U of Tx is equal to, because you take Tx, you hit here, so u of 0 x naught, that is h of x naught. You can substitute x naught as x minus 80. Why? I can tell you why. Just a definition for a straight line. Here is the point x comma t, right? T comma sorry x comma t. So this is the A hitting at the point A. So what is the equation of the straight line? S comma AS plus x naught. Agreed? This is a straight line. Agreed? Just see, we have done this. Your T naught is 0. Your T naught is 0. So T naught is 0 because it's starting from the x-axis. So S comma AS plus x naught. This is gamma S. Yes or no? So your gamma S is this. Okay? Yes or no? Okay. Let's say at the time S equal to S naught, this straight line. This is a straight line. Okay. At the time S equal to S naught, the straight line reaches at the point x tx. At the point t of comma x. So this straight line starting from here. Okay. When it is started with a slope A, it reaches at this point tx. Yes. So what should be happen? What should happen? So your S comma AS plus x naught should be equal to t comma x. That is S equal to t and AS plus x naught should be equal to x. Clear? So you can substitute here AS minus x, sorry, x naught is x minus AS, but we want in terms of t, S equal to t. So x minus 8. Clear or not? This is the straight line S comma AS plus x naught, right? It started from the point here with slope A. It reaches at the point Tx at, let's say, at the time, because this is a parameterized with S. So let us take at the time S equal to S naught, this straight line reaches the point T comma X. Then S comma AS plus x naught equal to Tx, that is S equal to T and this. So you can substitute x equal to x plus 80. So u of Tx is nothing but u of 0x because of this, because u is constant along this straight line, that is equal to h of x naught. And what is x naught? So the solution is, so the, if u is the solution, then the solution should look like u of t of x should be h of x minus 80. If u is a solution, then utx should look like. Now what we have to, is it, now you tell me, is it clear or not? Unless this is clear, we can't go forward, because we will be using this next for the next 1 month at least. I will do another 2-3 examples, but please let me know whether this is clear or not. Think and tell me. I give you 2 minutes. Please, I will repeat again if you wish.
So
Yes,
can
sir.
you
Please
summarize
repeat.
it?
Huh?
Please repeat, sir.
Yes.
So, please repeat. Okay, sure. So this is the equation we would like to solve. ut plus aux equal to 0. When there is a problem, please let me know. Okay, I will stop here. Ut plus aux equal to 0, u naught of x equal to hx. Just draw the picture first. This is the where it is initial condition is given here along the x-axis, right? So this is, you know, u naught of x is equal to h of x. Okay, and this is the equation. First we assume a equal to 0. When a equal to 0, then u is a constant along t variable. So any point xt, you just drop a line. This is the solution. So h of x equal to u naught of x. U is constant along t. So u naught of x should be equal to ut of x for each x. This is clear because ut is equal to 0. That means u is a constant along t variable. So the value of u t of x should be equal to u0 of x. And what is the value of u0 of x? Hx. So the solution utx, we get a solution utx equal to hx for all t if a is 0. Next case, when a is not equal to 0, we have to solve this. Okay, I take a curve gamma of s ts xs, a curve in and let us and curve in this t comma or t cross r domain. Okay, this domain. Okay, now I define a function v of s, which is this is a single variable function, because how I define it with a composition function u of gamma s. What is u? What is u? U is a function which solves this. So we want to see how the solution looks like. So we see that if let us assume first u is a solution. Let us assume. Then the v of s, u of gamma s. Clear? Clear? Okay.
Yes, sir.
Then what I did a chain rule. V prime of s is, if you do the chain rule, you will have this. This is clear, this statement up to this?
Yes, sir.
Okay.
Yes, sir.
Now what I did? Now I impose a condition. Suppose t prime of s is equal to 1 and x prime of s equal to a. Then what is v prime of s? Then v prime of s is ut plus aux equal to 0. Yes, along this curve, along this curve. Okay. Once it is 0, provided t prime of s equal to 1 and x prime of s equal to a. So you just first solve t prime of s equal to a, and what is x prime of s equal to a? T prime of s equal to 1, x prime of s equal to a imply t of s equal to s plus t naught, xs equal to a plus x naught. Clear? And the what is t comma? So gamma s is nothing but is the straight line. T naught is 0 because why t naught? What is t of 0? T of 0 is t naught. But we know that this is a straight line hitting the x-axis. In the x-axis, what is the value of t? What is the value of t?
0.
0. So t naught is 0. So you have immediately got t0 is 0. Sorry, t naught is 0. This is the initial condition. Okay. Now this is a straight line. What is this straight line? So this is a straight line. X plus t naught, as plus t naught. So this is a straight line with slope a. Clear? Because a cannot be 0 because already 0 I have taken, a not equal to 0. So it has to intersect somewhere. Yes or no? Clear? Yes or no? Yes or no? Hello?
Yes, sir.
Yes, sir, it's clear.
Now who said that it is not clear? Now is it clear? Huh? Who said now? Now or I will repeat again.
Yes, sir. Clear.
Clear. Please tell me. I will repeat. There is nothing to worry. I will repeat again and again. Is it clear? Okay. So what we prove, v prime of s equal to 0 when it is 0 along the curve gamma. What is the curve gamma? So v is a constant on gamma if gamma is a straight line with slope a. That means u is a constant. U is, that means v. How will the v is defined? V is defined as u of gamma s. So this means that u is constant along the straight line gamma s. So u is constant along the straight line gamma s. Okay. So now we have to prove that. Okay, this is done. So now you have this along straight line, u is constant. Now let us specify some point x comma t. We want to find u of xt. What you will do? You just drop a straight line here. So what will be the u of xt? The value of u of xt should be equal to u of 0x along this straight line. Okay. Once you do that, so v of s of u of x naught, ut of x as u any point u xt. Sorry, I should write xt or tx. That is xt u naught of x naught. So h of x naught. But now you have to find what is x naught, because x naught is from anywhere you can hit at x naught. So x naught is just using the concept of a straight line. You can compute x naught is nothing but x minus 80. So the utx. So if u is a solution, then you should look like this. Clear? Now conversely, assume h is a C1 function. Then utx define h of x minus 80. So what utx will satisfy? Conversely, now this is the utx will look like h of x minus 80 if u is a solution. Now you have to show that converse part also. Conversely, assume h is a C1 function. Then if you define a function utx as h of x minus 80, then this you will satisfy our PDE. Yes or no? Yes or no? With the initial boundary condition, why? U naught of x equal to h of x. So it satisfies the boundary condition, and ut of xt plus a of ux of xt equal to 0 for utx equal to h of x minus 80. So this proves that uxt h of x minus 80 is a solution to the PDE. Clear? Clear?
Sir,
Yes.
in the question, t is strictly greater than 0. So how
Uh,
t naught can be 0?
T naught T. What is that? U of tx. I have specified what is the value of u0 of x. Yes. So when we draw the curve, gamma of s is t of s, x of s. What is t of s? This is s plus t naught. So this is a straight line, right? So a straight line which is not parallel to x-axis. It should hit some point at x-axis. Yes or no? If it is not a parallel to x-axis. Yes or no? Parallel cannot happen. We have removed a not equal to 0 case. So it should hit TS. Yes or no?
Yes, sir.
Then T of 0 should be T naught. So if it hits at x-axis, it should be equal to 0. Yes or no? Yes or no? Because you have to find utx for t positive, but we already know u naught of x. This is the initial. That is why it's very important to have an initial condition. That is why we said that it is a well posed if there is if it's a solution, it satisfies the boundary condition and all those things. Okay. So this is a boundary condition. U0 of x. We are prescribing the value of u at 0x. At the boundary, we are prescribing the equation, the value of u naught, the solution, which is equal to hx. You understand?
Yes,
Did
sir.
you understand? Oh, okay, good. Okay. Now let us do another example. Another example. Example 2. You should tell me now. Now your favorite u of xy plus u of xy equal to 0 when xy is in R2, and u of x comma 0 is given to be some gx when x. Now we want to solve this PDE here everywhere. So where it yeah, when x equal to 0, here it is given. Here u of x comma 0 is equal to gx. Who will solve this? Hmm? Sorry. XY R cross 0 infinity. Let's say. Okay. Same thing, right? Instead of A now, I have put A equal to 1. So what should be the solution? Anyone? So what should be the
G
solution?
of x minus y.
U of xy is G of x minus 1. This is the solution. Provided G is a C1 function. Provided G is a C1 function. Why? Who will tell me why? Hmm? Who will solve this? The same thing, man. A equal to 1. Who will solve this? Mahesh?
What, sir?
So how to solve this? Same thing, right?
We just put A is equal to 1 here.
Yeah, that's it. So this is the solution. Okay. Now I give you a little bit difficult one. Example 3. U of x xy plus u of y xy is equal to u. Now, which type of PD is classification? Which type of PD is this in R2? Which type of PD is this?
Semi-linear.
Very good. This is a semi-linear PD. Very good. You have to ux xy plus uy xy equal to u. Now you have to solve this. How to solve this? Who will tell? Who will help me to do this problem? Yash, you want to do this?
We can do by the same process.
Same thing. What you will do? Tell me. First, take a
Yes.
curve, right? Take a curve, right?
Yes.
Gamma of t is xt, yt. Now, what we will do? Define v of t is u of gamma t. That is u of xt, yt. Okay. Now, suppose. So, what I have? Vt is u of xt, yt. Okay. So, v prime of t is ux at the point xt, yt, x prime t plus uy at the point xt, yt, y prime t. Okay. Now you suppose same trick. Suppose x prime t equal to 1 and what is y prime t? Okay. Suppose. Then what is v prime t? V prime t is nothing but ux at the point xt, yt plus uy at the point xt, yt. Yes or no? Yes or no?
Yes, sir.
Okay. Now suppose u is the solution. Then what will be this equal to?
U.
U of
U it's
you have to u of
Right.
you have to be careful along this curve only. We are doing along this curve. So u of at the point xt, yt. What is u of at the point xt, yt?
VT.
Very good. Yeah. So we have three equations now. V prime t equal to Vt, x prime t equal to 1, y prime t equal to 1. Okay, we have a system of three equations. V prime t equal to V, x prime t equal to 1, and y prime t equal to 1. So what will you get from this? Again, right? This is the what you will get. Xt is equal to
T plus x naught.
t plus very good. Yt is equal to
Y plus T plus y naught.
exactly. So what is the curve? So the curve gamma t as xt comma yt is what is that? T plus x naught, t plus y naught. This is nothing but t 1 comma 1 plus x naught y naught. What is this curve? Huh?
Straight line with slope 1.
Yes. So gamma t is a line with slope 1. Very good. Now another equation is there, right? V prime t equal to Vt. Can anyone tell me immediately what is Vt? This you have done in OD. This is an ODE, right? We are converting this PD into OD. What is V prime t equal to Vt? What is Vt? Come on. What is that?
K की power t.
E raised to t.
Exact. Yes. Vt is equal to a constant time e to the power t, because there should be a constant, right? A constant time e to the power t. So what from these three equations what we obtain? Along these straight lines, Vt should be c into e to the power t. That means u of gamma t is equal to e some constant time e to the power t along these straight lines. This is not now it's not constant. So along this straight line, because this is u z equal to u of x. This is a surface, right? Along this straight line, u is a function of exponential to the power t. Clear or not? Because now you cannot tell that the function here should be equal to function here, because this is not constant along this straight line. And here we know that u x comma 0 is g of x or something like that, g of x. Okay. Now how to do this?
You can find C.
Try. What you will do now?
Put
What is
T
V0?
equals
First of all, first job is to find C, right? Yes or no? Yes, you agree?
so
What is V0? Can anyone tell me what is V0?
U x y naught.
U of, very good, U of x0, y0. What is x0, y0?
It's not
Starts from here. What is y0? What is y at 0?
y naught.
Huh?
0.
What
0.
is y at 0? 0. It starts from here, right?
So
Tell me.
not 0.
Yeah, very good. X0, let's say x0, comma 0. So u of x0 comma 0 is g of x0. So what is the value of c? What happened? What is the value of c? G of x0, e to the power t. Agreed? Vt equal to g of x naught e to the power t. Agreed or not?
Yes, sir.
Okay. But now your work has not been done, right? Now later you have to work more. You have just proved that. Of course, you know what is x naught. Do you know what is x naught? Again, the same trick, right? What happened? Xy. Because this is a straight line. When the line will hit xy, just tell me what is x naught. Again, the same, right? What is x naught?
X minus t.
X
X minus y. X minus
Yeah.
y here. Let us do it. But now you have just proved that u of what is u of xt yt is equal to g of x naught e to the power t. This you have, this much you have proved, not more than that. You have proved you have find u at the line, along this line only, which behavior gx as x naught, like this. This is important. You have just proved the u at xt yt, it looks like this. But now what we have to do? You have to find for any along, not along this line, for any xy, right? Let xy belongs to R2. We want to find u at the point of xy. What we will do now?
So I think first we will try to write t in terms of x and y.
Exactly. T in terms of x and y. So you define just for your a new curve gamma prime t as x minus y plus t comma t. This is a straight line with slope 1. Yes or no? Yes or no? Fix any xy. Let xy be any point in R2. I define a gamma t. Is this a straight line with slope 1? Huh? What happened? What is the slope of this straight line?
one.
So some line it is there. So this passes through gamma prime bar of y. What is gamma y? If you put equal to t equal to y, you have clear? This gamma prime t, if this is a straight line with slope 1, this passes through xy. Yes or no?
Yes, sir.
Yes or no? Agreed? Agreed or not?
Yes, sir.
This passes through x and y. Gamma y is passes through at the point y, it passes through xy. Yes. Okay. Passes through this gamma t passes through xy at the point y. Okay. Now we have Vt. We know that Vt equal to g of x naught into e to the power t. Now V of y, because I have to write t in terms of x and y. V of y is g of x naught e to the power y. And what is V of y? V of y is, what is V of y? What is V of y? U of gamma y, gamma prime of y. Sorry, the same gamma. Sorry, this is the same gamma. Same. Gamma of u of gamma of y. What is u of gamma y? Gamma y is x and y. U of gamma y is u of x comma y. So we have u of x comma y is g of x naught into e to the power y. Clear? And what is x naught? As previously, this is x minus y. Clear or not? Tell me. If you wish, I will repeat again. Tell me. Everyone. Everyone. All of you say yes, then only I will move. As he mentioned, we have to, this is for, we have proof for any x comma t. Now what we have to do? Now we have to inverse it. In terms of t, it is given. Now we have to find in terms of x and y. So just usual trick. Find a curve which passing through x and y with slope 1. This is a straight line. This is a straight line gamma t, x minus y plus t comma t. This passes through xy at the point gamma of y. New of what is called gamma of y, xy. Okay. Once you have this, you vt equal to this. You put t in terms of y. You put y. V of y equal to g of x naught e to the power y. What is v of y? U of v of y is u of gamma y. And what is gamma y? Is nothing but a point xy. So u of xy is equal to g of x naught e to the power y, right? And you know how to prove that x naught. X naught is again you can do it for any xy. This is x naught comma 0. You reach at the point xy. It's the same calculations. If you do that, you will get x naught is equal to x minus y. So what we are doing? We are inverting the t variable in terms of x and y. This is nothing but this is now when we will do something in more a general way, we will see that what is there. That means xt, this x comma y, this x comma y, this is xt yt. We are inverting this map. We are inverting this map. We are inverting this map. We are inverting this map xy to xt yt. We find in terms of x and yt. Now we want the solution should be in terms of x and y. So we just invert it here. And for that we use some kind of special trick that gamma t, you have to find a straight line passing through x and y and a slope of 1. So this is a straight line. Gamma t x minus y plus t. This is the parameterization of a straight line. So it passes through the line xy at the point y. Okay. And this way we compute xy. You tell me, is it clear or not? Everyone.
So can we take any gamma?
Yes.
Are we free to choose?
You have to, but you have to you have to find this. This is like nothing but an inverse function. You understand? You have to find some kind of gamma t which giving you xy. Some kind of inverse thing is going on here. You understand? Now can anyone tell me what is xy if this map xy going to xt yt is invertible or not? So some kind of inverse function theorem we are using in two variables. Okay, if the determinant of the matrix, that Jacobian matrix, is non-zero, then we can inverse this to map. Okay, under this, we will see. This is just an today only I did some examples. Okay, next class we will do this. We will do the theory. What is the theory behind this? Okay. Yeah, if you can take any curve, but we know that v is taking the value gx naught e to the power t only along this straight line. So any curve if you take, you don't know the value of v along this curve. You know only the value of v along the straight line with slope 1. You understand? So any curve will not work. So you have to find some gamma t which is a straight line passing through the line xy. Is it clear? All of you? Because v is constant, then this is life is easy. You just plug it there. But when you know that the function of v is in terms of t, here is also t. So you have to find a curve which for which v takes the value this. So for any curve, v is not taking the value this. Only for those straight line with slope 1 taking the value vt equal. That is why I can do this. That v of y is equal to g of ex to the power y. Because u of gamma y, this is a straight line. Along this straight line, v takes the value exponential. That is why we have to find a gamma which is a straight line with slope 1. Okay, is it clear?
Yes, sir.
All of you? Anu, Goel, Anshu, Ashish, Atharva, Deepak,
Yes, sir.
everyone, Divya, because this is very important. Ekta, Gitanjali, Gopal, Kritika, Mahesh, Manish, Manoj, Meenakshi, Nikita, everyone, it is clear? Sanjeev?
Yes, sir.
Yes, sir.
Sanjeev?
Yes, sir.
Yes, sir.
All of you? If you wish, I can repeat again. Anyone tell me? All of you clear? This is very important. I must say that unless you understand this, you will not understand the theory. So there are, now can you tell me what are the things going on? One thing is going on, as he mentioned, we have to write x and y in terms of xt, yt in terms of xy. There is some kind of inversion is going on. So not always you can invert it. So there is one problem. Here I can do it, but not always. Second is that this ODE should have a solution. We know that existence. So we will be, so when I am writing this, so this is a system of ODE. When the system of ODE has a solution, we know that always we, if it's ellipse is continuous, all you know that when it has a solution, right? When an ODE has a solution, Picard's theorem, you know, right? You know, right? All of you know the Picard's theorem? Yes or no?
Yes.
Okay. Okay. So there is some kind of the existence of, this is a ODE existence uniqueness plus this is some kind of inverse function theorem is going on. Inverse function theorem. So when we will do in a general form, we will see that these two plays very important role. Inverse function theorem and inverse function theorem plus inverse function theorem plus Picard's theorem, existence uniqueness. So when you come to the next class, please go just at least the statement of inverse function theorem and Picard's theorem. Please come with this too. Okay? Because next class I will do a more general theory. One more example, then I will stop. Now consider a non-homogeneous problem. That means homogeneous problem. Ut plus AUX, A is a constant, same thing. Instead of 0, now we have f of tx. T positive xr. Okay? And similarly, u comma x is equal to h of x. Instead of 0, now we have a function ftx. What we will do? Who will solve this? If we do the same process, what will be the resulting equation? Anyone? One thing again, this t prime of s equal to 1, x prime of s equal to a, and another is v prime of s is
F of tx.
exactly f of ts, comma, you should be precise, xs. Okay, so this is a 3 equation. But we know that ts we can write down as f of t. You know what is ts from here. Ts is t plus some t naught sorry, S naught, sorry, T naught plus S, sorry, T naught plus S, comma, X naught plus AS. So we are now in this form. V prime of S, nothing but f of T naught plus S, comma, X naught plus AS. Now what you will do? What you will do? You should know this. What to do? What you can write? V prime of S is this. So fundamental theorem of integral calculus you use. What is V0 minus V of minus T? Huh? This is nothing but 0 to minus T V prime of S ds, which is nothing. I can write this, right? Yes or no? Yes or no?
Yes, sir. Yes, sir.
Write down. Otherwise you have to do T naught. No problem. Anyway, I just single variable T I made it just a running variable. No problem. So this is 0 to minus T f of T plus S. Or otherwise, if I do T naught, I have to make T naught. Okay, no issues. So if you want it, I can take T naught. Otherwise, you have to write T naught here. Okay, comma X plus AS. You can make T naught. So V naught minus V of minus T. Just using the fundamental theorem integral calculus. Now, what is V0 and V of minus T? Can you calculate? Also, V at 0 minus V of minus T is, what is V of 0? U of T0 minus X0 minus U of T of minus T, X of minus T. So we have V0 minus V of minus, this is just nothing. This is U of T0 X0 minus U of T minus T, T of minus T, X of minus T. If you write down it, this is U of Tx minus U of 0 comma X minus AT. So this is U of Tx minus, what is U of X 0 X, H of X minus AT. Okay, clear? Therefore, U of Tx is equal to H of X minus AT plus 0 to minus T f of, because if it is 0, then this term was not there. Only ut of is 0. Since it's a non-homogeneous problem, you have this part. Is it clear or not? Is it clear or not? Nothing, you just compute and you will see.
Sir, can you explain the second line? Like, how did we go from first line to the second line?
Here to here.
In this page only. Here to here.
What I have defined? T of S is T plus S. T of minus T is 0. Because, you understand?
Okay, yes, sir, yes.
T of minus T, you have to take a backward. You understand? Backward. T of minus.
Yes, sir, I got it.
X of minus T is nothing but it is T, X of S is X plus AS. So X of minus T is X minus AT. So from here, Clear? Yeah, just we have to find h of x p. Nothing. Okay. Okay, clear? All of us, it is clear to all of us? All of you, is it clear to all of you? Yes or no? Is it clear to all of you? Same thing, just this term will come, nothing, this extra term will come. Because of the non-homogeneous part. So clear to all? Yes or no? Yes or no?
Yes, sir.
All of you?
Yes, sir.
Yes, sir.
Gopal,
Yes, sir.
clear?
Yes.
Yes. Manish, you go home. Please try to solve these 3 or 4 examples again. Okay? Otherwise, next class I will be doing theory. So it will be so. And before coming to the class, have a look on the inverse function theorem plus what I said, existence and uniqueness of ODE. Okay? Just a statement will be enough. Okay?
Sir,
Both yeah.
sir, please upload both lecture PDF note.
Yeah. Sorry. Today I will upload. I intentionally did not do the for first lecture. I saw that first lecture there was nothing, so I will put today together lecture 1 and lecture 2 the PDF. Okay. Please go through those PDF again and again. Okay. At least these 3
Okay,
examples. Okay. At least 3-4 examples, and please come with just a statement. It will take 5 minutes. Have a look on the statement of inverse function theorem plus the Picard's theorem. Is it okay?
Yes, sir. Okay, sir.
All of you, please do that. So please now tell me, is it are you following or not? Otherwise, I will explain again and again. Don't worry. I can understand this is a online semester. You might face some problem. So please tell me. Unless you tell me that this is a problem or you are not following, I will not able to understand. Okay. Please tell me. I will repeat again and again. I can take an extra class to make you understand. Plus, please tell me whether you are able to understand or not up to today's class, until today's class. Is it okay? All of you? Yes or
Sir,
no? Yes.
sir,
Yes.
we know how to solve these PDEs by there is a general method actually. So was it not easy to apply that, or
What are the
we
general?
have we
I never see this. What are the general method? I don't know.
means if we have like PD ux plus uy is equal to 1, say, then we consider dx by the coefficient of ux and dy by coefficient of that and then we make a pair of equations and then we use conditions to solve it directly. Or means is this method were coming out as a matter of fact, or just
No. Actually, what we will be doing, our main aim of this PD is not to solve explicitly the PDEs, to learn the analysis of PDE. You understand? We want to learn the analysis of PDE. Most of the in the later future, when who are doing a serious PDE theory, you cannot solve it. You can't solve explicitly. This is not like a chart pit method or something else that you can solve directly. Okay, maybe these problems can be solved very easily with some of your methods, but we are not learning methods. We are learning the theory. Okay, so you will see that I can pose any problem. I can give you a u square u to the power cube or something like that. We are not interested in solving PD. We want to interested whether this PD has a solution or not. We don't want an explicit solution. But with some methods of analysis, we will see that we are able to say that yes, there is a solution for this PDE without solving any methods or something, because methods on all those things can work for only a very particular class of PDE, not for all PDE, right? Right? Like BSc, what we did, that we just solved the PDE, what's PDE or OD or Charpin method and all these methods, but we don't know what is the theory behind this. In this course, we will be studying the theory behind this. Okay, we are not interested in solving the method. We are not interested in the methods. Okay, we are interested in the developing the theory for those methods. Okay, so when I will do a very general, so I can give you some e to the power u cube log u or some kind of PD, that ux plus uy equal to e to the power u square or u to the power 4. Can you solve this PD? Like this, if I give you, is there any method? I don't know at least. E to the power some u 4. What happened? Just a minute. It's not working. Just a minute. It's not working, man. It's not working. Sorry. So you understand what I'm saying? Ux plus uy is equal to e to the power u to the power 4. Can this PD solvable? Can you solve this PD with some method? Yes or no?
It's not solvable. It's
So we cannot solve with we cannot explicitly find the solution, but we will say that for such PD also there exists a solution. So we are interested in existence and uniqueness of the existence of the PD. You understand? Now you understand? Because ux plus uy equal to 0 can be solvable, yes, by some explicit method, but we are not interested in that method. Yeah, tell me. Yes.
Means these methods are consequence of what we are doing, means this analysis, right?
Exactly. Those are the some particular cases of that. Okay. So this course is meant for analysis of PDE. Okay. You will see lots of analysis we will be using later. In fact, I will not do that. If we do that in RNN, there is some differential geometry. Geometry also plays into. So we will do some geometry. See how this solution can be. We will frame this solution as the geometric surfaces and all those things. Okay. You will see in the next class. Okay. This is nothing but it's called. You will see. Integral surfaces. What is the solution of a PD? Is actually integral surface. Okay. These are deep. We'll not do in a deep way. Just we will mention that, but these are very Lie groups and all those things are related to this differential geometry and all those things related to this PDE theory. Okay. Anyway, we'll not do that. We'll just use the inverse function theorem and Picard's existence theorem. That's all. Okay. Clear? Yes.
Yes, sir.
Okay. Very good. Anything else you want to ask? Okay. But Monday you will surely tell me the date for the tutorial. Okay. Please decide yourself and let me know. Okay. Clear? Okay. Thank you. Thank you. So we meet on Monday. Thank you.